I first visited the building on Canal Street in New Orleans, officially recorded as constructed in 1883 by architect James Freret, expecting nothing more than another late Victorian municipal hall. A renovation file stored in the city archive labelled Plumbing Revision 1912 included an older photograph, a grainy 1884 image of the facade taken just after completion. At first glance it appeared ordinary: red brick, arched windows, decorative stone banding. But when I enlarged the left corner of the image, I noticed something the file never discussed: a perfectly symmetrical sub-arch beneath the main foundation line, half buried even then. It mirrored a structural pattern I had seen only in early Tartarian infrastructure maps, the kind researchers link to hydraulic pressure systems. The official documents described it as decorative bracing. Yet the stone dimensions and curvature ratios did not belong to any recorded 1880s construction methods. I should have dismissed it. But I did not. Something here was wrong. Quietly, deliberately wrong. The Municipal Hall's official record said construction began in late 1882 to accommodate expanding administrative offices. Freret's signature appears on the surviving blueprint, a thin, onion skin paper drawing filed in March 1883. The basement floor plan shows a simple storage level with no mechanical facilities. Yet when I stood in front of the foundation itself, the proportions contradicted that simplicity. The arch curvature radius measured 3.4 meters, a scale excessive for a storage sublevel, but consistent with load distribution arches found in pre-industrial sites across Eastern Europe. Territories once mapped as part of Great Tartary. The arch was out of place. A renovation order from 1912, handwritten in black ink, included one line that read, "Remove lower cavity, brick over obsolete channel." No mention of its purpose, no drawing. The cavity's dimensions matched the buried arch visible in the 1884 photograph, meaning the hall was built on top of an older foundation the city later sealed. If this substructure predates 1883, whose architecture did the city inherit? I returned to the photograph repeatedly. The sub-arch showed tooling precision inconsistent with hand-carved Victorian stonework. Each joint aligned within millimeters, suggesting mechanical cutting methods not documented in New Orleans until decades later. The deeper I looked, the more the foundation revealed its contradictions. Victorian construction typically employed rough-cut limestone, with joints varying between 5 and 15 millimeters. The sub-arch joints measured 2.8 millimeters with less than 0.3 millimeters variation across the entire visible span. I consulted engineering manuals from the 1880s. None described tools capable of producing such uniformity in field conditions. The stones themselves bore a surface finish smoother than period technology should have achieved. When I examined high-resolution scans of the 1884 photograph, I could see faint parallel grooves across the stone faces, marks consistent with rotary cutting, not hand chiseling. Decorative arches do not require pressure-bearing geometry. I traced related structures documented as built the same year. Along St. Charles Avenue, a utility annex added in 1885 showed a sealed passage on its eastern wall. City workers had bricked it over during a 1939 Works Progress Administration renovation. A small note in the project log states, "South corridor connects to earlier works, deemed unnecessary." Earlier works, yet the building supposedly had no predecessor. The symmetry of the bricked arch matched the buried sub-arch beneath Canal Street, down to a nearly identical rise to span ratio. When I overlaid the curves digitally, they differed by less than 2 centimeters. The match was striking. These matching geometries align with what Tartarian researchers identify as continuity signatures, repeating arches forming distributed hydraulic or energy systems. The evidence forces questions that official records do not answer. Looking at the brickwork, I saw 2 periods interwoven. Victorian patching over something older, smoother, more exact. The mortar ages differently. Victorian brick shows rough edges and irregular spacing. The older stonework beneath carries none of those imperfections. I measured the joint widths with calipers, 3 mm, consistent across the entire visible section. Hand tools produce variation. These joints showed none. The consistent measurement was striking. I spent an afternoon photographing the sealed doorway from multiple angles, noting how the Victorian brickwork sat awkwardly against the older arch. The builders had struggled to match the curve. Their bricks created a stepped approximation rather than a true arc. But the older arch beneath showed a perfect parabolic curve, mathematically precise. I calculated the formula. The arch followed a catenary curve with a parameter of 2.1 meters, the optimal shape for distributing compressive loads. Victorian architects knew catenary principles, but implementing them with such precision in underground construction would have required surveying equipment and mathematical tables beyond what the 1880s project budgets documented. The strangest detail appeared in a handwritten margin note on the 1939 renovation order. Do not photograph the interior before sealing. Someone wanted no record of what lay beyond that doorway. Why would two unconnected 1880s structures share identical sub-foundation geometry? A photograph in the Historic American Building Survey dated from 1871 to 1874, nearly a decade before the Municipal Hall, depicts the same block but shows no construction activity. Instead, a partially buried stone platform occupies the site. The caption simply reads, "Unidentified remains." Stone platforms of this kind are seldom Victorian. Their tooling marks resemble those at Starfort sites in territories once labelled Great Tartary on 18th century maps. The 1883 blueprint lists no excavation difficulties, no mention of earlier foundations, no notation of demolition, yet the photograph proves something stood there. Something deliberately uncredited. Each visible block measured approximately 1.6 meters in height. I consulted period engineering manuals to determine lifting capacity. New Orleans documented equipment in the 1870s, steam-powered cranes and block and tackle systems could reliably move stones up to 800 kilograms. Blocks of this size, assuming limestone density, would exceed 2,000 kilograms. The mathematics did not support the official silence. I traced the photographic negative to the Library of Congress collection. The original glass plate showed more detail than any published reproduction. In the foreground, partially obscured by vegetation, stood what appeared to be the top section of a dome, red brick with distinctive vertical ribbing. The dome's diameter, measured by comparing it to a visible human figure in the frame, exceeded 8 meters. No structure of that scale appears in any New Orleans construction record before 1880, yet there it sat, partially buried, in a photograph taken 7 years before the Municipal Hall's supposed groundbreaking. The photographer's field notes, preserved with the plate, included a single observation: structure appears fire damaged. Local inquiry yields no history. Fire damage suggests the structure was abandoned rather than demolished, but abandoned by whom? The city's fire records from 1850 to 1875 mention no conflagration at this location. The damage, whatever caused it, predated municipal memory. If the builders in 1883 did not place those stones, then who did, and why did the records avoid naming them? While studying the 1883 engineering journal entry by foreman Louis Charbonnet, I found his note: lower arches integrated with existing masonry, origin unknown. This single line undermines the idea of a ground-up Victorian project. The cross-section drawing that accompanies the entry depicts 2 layers of arches, the documented 1883 arch above, and a deeper, older arch of cleaner curvature and more precise joint spacing. The lower layer is hard to ignore. Using a software overlay, I compared the older arch with that of the annex on St. Charles Avenue. Their centroidal alignments matched within millimeters. Such alignment suggests a shared structural grid, a pattern often cited in Tartarian research, linking subterranean load paths to hydraulic distribution. The Victorian builders appear to have built into an existing framework rather than creating one. Charbonnet's drawings show reluctant acknowledgement. He sketched the older arch separately, with a question mark beside the notation. No attempt to explain it, just documentation of something already there. I examined the drawing under magnification. The older arch showed radial symmetry, precise to within 0.2 degrees across its entire span. Victorian hand drafting rarely achieved such consistency. More troubling, Charbonnet had drawn the arch in two different ink colors. The upper Victorian section appears in standard black drafting ink. The lower older section uses a faded brown ink, suggesting he had traced it from an earlier document, but no earlier document exists in the archive. That discrepancy hints at deliberate layering. I searched for other projects overseen by Charbonnet between 1880 and 1890. He supervised construction on 3 other municipal buildings in New Orleans, all showing similar notations: foundations encountered, existing vault incorporated, lower works of uncertain date. Each project's budget included line items for excavation and clearance, but nothing for demolition or removal of pre-existing structures. The pattern implied builders consistently found older infrastructure and built around it rather than removing it. The pattern repeats across projects. One final detail troubled me. Charbonnet's signature appears on documents until 1891, then vanishes. There is no death record, no retirement notice, no forwarding address in city directories. Why does the older arch show machining precision beyond anything available in New Orleans in the 1870s? A 1906 plumbing revision for the municipal hall reveals a diagram of underground piping. Most of it follows typical early 20th century cast iron systems, except for one element, a vaulted chamber measuring 4.2 by 3 meters, labeled obsolete cistern. Yet the chamber's walls were stone, not brick, and bore a fluted texture identical to chambers in Tiflis, Kazan, and Irkutsk, cities historically shown as part of Tartaria in atlases from the 1760s. Those chambers were documented as parts of pressure-fed distribution systems. I visited the basement during a scheduled inspection and found the chamber sealed with a concrete plug added in 1954. Thermal imaging showed colder zones around its perimeter, suggesting metal or voids inside. The fluted pattern creates turbulence in flowing water, increasing pressure efficiency. Victorian cisterns used smooth walls. This design reflected hydraulic engineering principles not widely documented until the 20th century. Yet here it existed beneath a building supposedly completed in 1883. The concrete plug bore no municipal stamp, only a date etched in marker that read 11/12/54. Someone sealed this deliberately, without official documentation. I filed a request to access the chamber. The facilities manager responded that no access had been granted since 1954 and that structural concerns prevented any current entry. When I pressed for details, he said the 1954 sealing order came from the city engineer's office, but the original work order had been misfiled and never recovered. I located a 1952 maintenance photograph taken before the sealing. The image showed the chamber's interior, walls covered in that distinctive fluted texture, and in the center what appeared to be a metal collar embedded in the floor, approximately 60 centimeters in diameter. The collar showed bolt holes at regular intervals, 8 holes spaced at exactly 45 degrees. This suggested a mounting point for machinery, Yet the 1906 diagram labeled the space as a cistern. Cisterns do not require floor-mounted machinery. The photograph's reverse side carried a stamped notation that chamber contents had been removed prior to sealing, disposal unrecorded. Whatever had been mounted to that floor collar, the city wanted no permanent record of its existence. Why would a standard municipal building contain a chamber resembling Tartarian hydraulic infrastructure? While reviewing archives from St. Louis, I found a photograph of the old post office foundation, built in 1873. Beneath its red brick Victorian facade lay the same triple-arched substructure I saw in New Orleans. The old post office builders attributed the arches to subterranean ventilation vaults. But ventilation vaults do not require precision stonework or 4-meter radii identical to those in Louisiana. Comparing measurements revealed a pattern. Arch rise identical within 1%, vault chamber dimensions nearly identical, stone tooling marks consistent across sites. I measured the old post office arches from archived engineering photographs using pixel ratio analysis. The rise-to-span ratio matched the New Orleans arches at 0.618. The golden ratio, a proportion appearing throughout what researchers identify as Tartarian architecture. Architectural coincidence rarely produces identical underground geometries across states separated by 1,100 kilometers. Tartarian researchers argue these are remnants of a pre-existing continental infrastructure lattice, hydraulic, electrical, or load-bearing. I was not ready to accept that, but the same sameness troubled me. Two architects working a decade apart in different cities without documented communication producing identical underground systems. I examined construction correspondence between the St. Louis project manager, Thomas Walsh, and the supervising architect, Alfred Mullett. In an 1872 letter, Walsh wrote, "Excavation has revealed substantial foundation works of unknown origin, proposed to incorporate rather than remove, as removal would delay project by 4 months minimum." Mullett's response, dated 3 weeks later, was terse. "Proceed as proposed. Document minimally." Document minimally, an instruction to avoid detailed records. The old post office was demolished in 1939. I found demolition photographs showing the moment crews exposed the underground arches. In one image, a worker stands beside a triple-arch section for scale. The arches tower over him, each standing nearly 5 meters tall. The demolition supervisor's report noted, "Substructure far more extensive than building plans indicated. Demolition required additional 2 weeks to clear underground sections not shown on any architectural drawing." Where did those underground sections lead? The report does not say. But a crew photograph from the same demolition, dated October 1939, shows a sealed tunnel entrance extending north from the building site, bricked over with the same style of closure I had seen in New Orleans. How did two unrelated Victorian projects replicate an underground system neither architect ever described? In the 1850 Mitchell map of Asia, the entire northern landmass is labeled Tartary. While disconnected from New Orleans geographically, researchers note the architectural signatures traveling with migrations and imported expertise. A shipping manifest from 1879, held in the Port of New Orleans archive, documents the arrival of stone-cutting specialists from Crimea. This is unusual. Crimea was not known for exporting stonemasons in that era. Their names, however, vanish from subsequent records. When I compared the tooling marks on the buried New Orleans stones with those in photographs of Crimean fortifications, they matched, showing smooth compression lines made by rotary cutters, a technology not attributed to either region in the 19th century. The compression pattern shows parallel grooves spaced 1.2 millimeters apart, consistent across samples separated by 8,000 kilometers. Hand chisels produce irregular spacing. These marks appeared machine-made. I searched census records for the Crimean specialists. Nothing after 1881. No death certificates, no departure records, no property transfers. They arrived, presumably worked, and disappeared from documentation. That rotary mark became my recurring motif, appearing everywhere something older had been buried. I found similar patterns in Boston, where the Custom House Foundation, dated 1877, revealed stones bearing identical rotary marks. The project engineer, William Preston, noted in his journal, "Foundation stones already present show superior cutting to any available locally. Origin, uninvestigated per instructions from municipal authority." Per instructions, someone had ordered him not to investigate. The rotary cutting pattern appears in photographs from across the former Tartarian territories, Kazan, Tobolsk, Astrakhan, and Samarkand. Always the same parallel compression grooves spaced between 1.1 and 1.3 millimeters. I compiled comparison images. Stones from 6 countries and 4 continents all show the same mechanical signature. The technology would have required powered rotary saws with diamond or carbide cutting edges, neither of which existed commercially in the 1870s. Yet these marks appeared on stones allegedly cut by hand in that exact period. The only alternative is that the stones were cut earlier, by methods later forgotten, and then reused or built around by Victorian-era construction. But if they were reused, why do the building's foundations show them still in their original positions, integrated into larger structural systems? Why do tooling marks in Louisiana match those in territories once mapped as Tartaria? A 1932 renovation file includes the line that says, "Remove metallic apparatus from lower chamber, no function." Yet they removed it carefully, noting bolt patterns and weight distribution. The document includes a rough sketch of what they extracted, a large ring-like structure with radial braces resembling a pressure regulator more than Victorian plumbing. Victorian regulators were cast iron with rough molds. The sketch showed perfect symmetry, impossible without precision machining. That ring shape appears in Tartarian research circles as part of unknown hydraulic systems found beneath demolished star forts. I compared the measured diameters. They matched within 0.3%. The sketch indicates 8 radial braces at exactly 45-degree intervals. The ring diameter measured 2.4 meters. Modern pressure regulators of equivalent scale require computer-aided design. Someone in 1932 recognized the apparatus was not Victorian, but they removed it anyway. The file notes disposed to scrapyard March 14, 1932. I contacted the scrapyard historical records. No matching entry exists. Either the disposal was not recorded or the apparatus went somewhere else. The sketch remains the only evidence it existed. The missing record at the scrapyard deepens the mystery. I found 3 similar removal orders from the same year: Boston, Philadelphia, and Chicago. Each described metallic apparatus or unidentified ironwork removed from subterranean chambers during renovation projects. Each order carefully documented dimensions and weight. Philadelphia apparatus weighed 340 kilograms, requiring a crane for extraction. None explained the machinery's original purpose. The simultaneous removals across multiple cities suggested coordinated action, yet no federal or municipal directive appears in the archives. A Chicago removal order included one additional detail that caught my attention. Apparatus shows no corrosion despite evident age and exposure to moisture. Metal composition undetermined. No corrosion. Cast iron corrodes readily in damp conditions. The apparatus, whatever its composition, had survived decades in a basement chamber without rust. That implied either an exotic alloy or surface treatment beyond 19th century metallurgy. I interviewed the grandson of the New Orleans renovation supervisor who oversaw the 1932 removal. He recalled his grandfather saying the extracted ring looked like it belonged in a power plant, not a basement, and that somebody important wanted it gone quickly. What Victorian building includes hydraulic machinery no one claimed to have installed? The question points to an unknown layer of infrastructure that our records do not explain. Researching San Francisco, I found photographs from 1895 taken before the earthquake that show onion-domed pumping stations built over substructures nearly identical to those beneath New Orleans and St. Louis. A 1907 engineering report noted that lower chambers appear older than surface works, and the origin is unclear. The pattern hardened. Buildings from the 1880s had been constructed atop older structures. Renovation logs referenced earlier unidentified works, and machined stone and structural precision predated official timelines. This pattern aligns with the Tartarian hypothesis that cities were built over older infrastructures belonging to a forgotten or erased civilization. Mainstream historians call the older structures preparatory works, yet none appear in municipal budgets of the time. I searched appropriations records from San Francisco, St. Louis, and New Orleans between 1870 and 1890. There are no line items for foundation excavation or removal of pre-existing structures. The budgets assume virgin ground, but the photographs show otherwise. Images taken before construction consistently reveal partial structures already present, platforms, arches, and chambers that final building plans never acknowledge. The omission appears systematic. The San Francisco pumping stations troubled me. Built in 1894 and 1896, they featured distinctive onion domes in red brick, a design element associated with Tartarian architecture in Russia and Central Asia. Yet the architect William Curlett had no documented exposure to Russian design. His previous work showed conventional Victorian styling. When asked about the dome design in an 1895 interview, Curlett gave an oddly vague response that the form suggested itself based on the site's requirements. Site requirements do not typically demand onion domes. Beneath those domes, the pumping stations contain the same vaulted chambers, the same precision arches, and the same unexplained substructures found in Louisiana and Missouri. The 1907 report by city engineer Karl Grunsky included detailed measurements of the underground sections. His findings noted that chamber volumes exceed operational needs by a factor of 3, that the stonework predates station construction by an undetermined interval, and that the purpose of the excessive volume is unknown. Excessive volume suggests the chambers were designed for functions beyond simple water pumping, but the station's official purpose never varied from their documented role, distributing water pressure through the city's mains. Why build chambers 3 times larger than necessary? Why do 3 cities show older foundations no one paid to build? A recurring architectural motif emerges across continents: perfect radius arches, subterranean hydraulic vaults, rotary cut stone, identical load-bearing geometries, chambers sealed during the mid-20th century. These signatures appear in Amsterdam, St. Petersburg, Istanbul, Buenos Aires, Boston, and New Orleans, all in buildings supposedly built between 1860 and 1890. Yet the tooling marks and subterranean geometries match photographs from territories labeled Tartaria in pre-1850 atlases. I compiled a database of 47 structures across 12 cities that show these characteristics. The statistical probability of independent development approached 0. Engineers in different countries, working without international coordination, produced identical underground systems using technologies not officially documented. The Amsterdam Central Station, completed in 1889, reveals triple-arched substructures photographed during foundation work in 1882. The arches match those in New Orleans within 2% variance. St. Petersburg-Vitebsky Railway Station, built in 1904, incorporated pre-existing vaulted chambers that construction logs describe as origin indeterminate. The more I compared, the less plausible coincidence became. I created dimensional overlays of underground arches from 7 cities. When scaled to the same size, the curves aligned almost perfectly. The average deviation measured just 1.7%, well within what would be expected from measurement error in historical photographs. This was not similarity, it was near identity. The probability of 7 independent architectural projects producing curves, this closely matched, was less than 0.0001%. The Buenos Aires Customs House, built in 1857, predated most American examples. Excavation photographs from 1855 showed the construction crew uncovering extensive brick vaulting of unknown age, according to the project superintendent's diary. The vaulting remained incorporated into the building foundation. A 1973 renovation exposed these vaults again, and the contractor report noted that the brickwork shows manufacturing precision inconsistent with 1850s Argentine industrial capacity. Istanbul presented the most striking example. Sirkeçi Terminal, completed in 1890, was officially recorded as built over Byzantine-era foundations. Photographs of those foundations showed the same rotary cut stone, the same arch proportions, the same fluted chamber walls found in New Orleans. Byzantine stonework typically shows different characteristics, larger blocks, cruder joints, and distinct tooling patterns. These foundations matched the Tartarian signature, not the Byzantine one. Why does architecture buried under 19th century America match infrastructure beneath cities 6,000 miles away? Renovation logs across cities record a striking pattern between 1930 and 1960. Removal of obsolete chambers, sealing of subarches, disposal of unidentifiable metal apparatus, and backfilling of lower vaults with concrete. One New Orleans entry from 1954 simply reads, "Finalize erasure of earlier works," again unnamed. This period coincides with a wave of historical standardization in which older, ambiguous structures were reassigned Victorian origins. I examined municipal renovation budgets from this era. Sealing operations received federal funding under infrastructure modernization programs. The work happened simultaneously across cities with no apparent coordination, yet followed identical procedures, including concrete plugs, filled chambers, removed apparatus, and sealed access points. A 1947 Boston renovation file states that lower vaults present structural ambiguity and recommends permanent sealing. Structural ambiguity is a bureaucratic phrase meaning they could not explain what they had found. I kept looking for a mundane explanation. None fit. The systematization implied centralized decision-making, yet no central authority appears in the records. I discovered something disturbing while reviewing federal infrastructure funding from this period. Between 1945 and 1960, a line item began appearing in appropriations bills titled Historical Infrastructure Remediation. The program disbursed approximately $43 million to municipalities for modernization of obsolete underground works. That sum is roughly $400 million today. The funding specifically targeted pre-1900 buildings with ambiguous foundation elements. No detailed accounting exists for how cities spent these funds. Renovation records show a surge in basement sealing, chamber filling, and tunnel closure matching the funding period. Philadelphia sealed 23 underground chambers between 1948 and 1952. Chicago filled basement vaults in 31 municipal buildings between 1946 and 1955. New Orleans, St. Louis, Boston, and San Francisco all conducted similar operations in the same time frame. A 1951 memo from the Boston Public Works Department mentioned that sealing work follows federal guidelines for remediation of pre-Victorian structural elements. Guidelines from which federal agency are not specified. I filed freedom of information requests with multiple agencies, none acknowledged issuing such guidelines. The coordinated erasure troubled me more than the original structures. Someone, at some level of authority, wanted those chambers sealed, those systems removed, those ambiguities eliminated, and they wanted it done within a specific window of time. Why did cities nationwide seal or destroy the same type of subterranean infrastructure within the same 30-year window? The structural alignments, machining signatures, and hydraulic chambers all suggest Victorian builders inherited pre-existing frameworks. Not super advanced technology, just engineering beyond what records attribute to the 1800s. A quiet line in an 1887 engineering journal chills me. Lower vaults are older. We adjust, not construct. If these vaults were remnants of an earlier network, then 19th century cities were built atop infrastructures they barely understood. Some researchers call this inheritance, not as a civilization with magic, but as a lost engineering tradition erased by later municipal revisions. The journal entry came from Detroit in a report on the Wayne County building completed in 1886. The engineer, Martin Coriel, sketched the existing vaults he encountered during excavation. His drawings show the same radial symmetry, the same proportions, the same tooling marks. Coriel wrote one more line. Uncertain what purpose these served, foundation proceeds regardless. He built on top of something he could not explain. His journals document 4 other Detroit projects between 1884 and 1891. Each encountered pre-existing underground structures. Each time he incorporated them rather than removed them. In his final journal entry before his death in 1893, Coriel wrote something that stayed with me. I have built atop the works of better engineers than myself. Their names are lost, their works remain. This acknowledgement of inheritance appears sporadically in period documents, just enough to confirm Victorian builders knew they were building over older systems, not enough to preserve any coherent explanation. An 1889 construction manual published in Boston included a chapter on encountering prior foundations, which advised, when excavation reveals stonework of evident antiquity and superior construction, incorporate such works into the new building's foundation. Removal is typically more costly than integration. The manual assumed builders would regularly find older foundations. It treated this as routine, not anomalous. But routine implies frequency, and frequency implies scale. If builders across American cities regularly encountered superior prior stonework, then the infrastructure beneath those cities must have been extensive, far more extensive than the scattered examples I had documented. I calculated a conservative estimate. If even 10% of major civic buildings constructed between 1860 and 1900 incorporated prior foundations, that suggests hundreds of pre-Victorian structures once existed across American cities alone. Why did Victorian builders admit the foundations were older but never identify who built them? In the final photograph I examined, an 1884 image of the Canal Street Municipal Hall, the buried subarch appears crisp, intentional, part of a larger grid now inaccessible. The Victorian facade sits politely above, like a later tenant unaware of the host below. By the time the 1954 concrete plug sealed the last chamber, the older system was effectively erased. The city above flourished, the city below forgotten. I revisit the photo sometimes. The stone looks patient, waiting. The pattern I traced across continents, identical arches, hydraulic chambers, rotary cut precision, systematic erasure, aligns disturbingly well with what Tartarian researchers have pointed to for years. Not as proof, but as the most persistent shadow over the evidence. The foundations remain. The records remain silent. And beneath modern cities, something older than their official histories continues to exist, sealed but not destroyed, forgotten but not gone. The Canal Street photograph showed one detail I had not noticed initially. A water stain on the sub-arch surface ran vertically from the joint line. Water stains normally run downward. This one ran upward, suggesting water under pressure flowing through the stonework itself. Hydraulic systems can push water upward. Decorative foundations do not require pressurized water flow. I made one final attempt to access the sealed chamber beneath the municipal hall. The request was denied without explanation. But standing outside the building, looking at where I knew that chamber lay beneath 15 feet of concrete and earth, I understood something. They sealed it, not because it was dangerous, but because it was inexplicable, because acknowledging it would require rewriting a history already set in stone. A blurred 1884 photograph of a buried arch, precise, silent, older than the city built over it, lingers without explanation. The sub-arch remains there still, bearing the weight of a building that history says should not exist, above foundations that history says should not exist below. Both persist. Both defy the simple story we tell ourselves about how our cities came to be.